Now, let's see how we can test a SOAP service published with GeneXus from GeneXus itself, importing it as an external object. Then, we'll focus on some more advanced concepts that make it more flexible to consume these types of services. To import the SOAP service we published, we go to Tools, Application Integration, WSDL Import, and write the same WSDL we tested before. In step 2 of the wizard, we type the name of a destination folder and press Next. In step 3, we see the structure of the service with 2 nodes. If we open the service description node, we find a single method called execute, and if we click on it, we see in the screen on the right that it receives the country identifier, country ID, as a parameter. By going to the KB Explorer, we can see that the folder we defined was created, and if we open it, the external object appears. If we open the object, we can see that it has only one method defined, called execute, and that it receives by parameter the country ID as we programmed it in the procedure. Now, to test the web service that we published, we create a web panel named Attractions by Country from WS and set it as main. In its variable section, we define the country ID variable and an STT attractions variable that's based on the STT collection of the same name. We also create a variable with the same name as that of the external object, so that it's of that type. We define the country ID variable for the form as a dynamic combo with the item descriptions property set to country name and the empty item property set to true. In the events, we program the control value changed event of the dynamic combo box so that when we choose a country, the event is triggered. Inside the event, we write the invocation to the web service using the variable getAttractionsByCountry WS period execute and passing as parameter the country identifier. We place this invocation inside the brackets of the from.json method of the variable STT attractions, which will contain the collection of attractions returned by our web service. If we run the web panel, we see that by choosing a country, all the tourist attractions of that country are displayed, returned by our web service that accessed the database to obtain them. Let's also test the service we published with 2 methods. To invoke the service, we made a copy of the web panel we had created. We added 2 buttons with the captions All Attractions by Country and Attractions by Country with Trips. We created the variable with the same name as the external object and commented the control value changed event. In the event of the first button, we make an invocation similar to the one that we had using the new variable and invoking the All Attractions by Country method, passing it as parameter the country ID. We do the same for the event of the second button. That is, we invoke Attractions by Country with Trips, passing it as parameter the country ID and the value 2, so that it retrieves only the attractions of the selected country that have at least 2 trips. We execute the web panel because it's main. We select the country France, press the first button, and see that it brings all the attractions of France. If we press the second button, it brings the Eiffel Tower and the Matisse Museum, which are the only ones that have more than 1 trip registered. If we open Work with Trips, we verify that only these attractions in France have more than 1 trip registered. Something that should be taken into account for web services is the security of the information that's transmitted. In general, when it's mandatory that the data structure and operations remain unchanged and authentication or sessions are required, the SOAP protocol is used. To add security to the SOAP message, many service providers use the WS Security Protocol, which adds a digital signature, encryption, and authentication methods that ensure the integrity of the message. In other words, that the message was not modified during transmission, its confidentiality, that the message is not seen by third parties, and that the authentication is secure, that the message credentials are not compromised. This security is added at the web server level using specific third-party tools. The mechanism is based on modifying SOAP messages, specific SOAP headers are included, and the SOAP body is modified with information used to ensure integrity and confidentiality. These modifications involve adding a security token specifying the credentials of the message author, adding a description of how the message is signed, the key used, algorithm, what part of the message is signed, and its signature. And also adding a description of how the message is encrypted, encryption key, algorithm, and what part of the message is encrypted. With GeneXus, we do not publish web services with WS security, but we can consume third-party services that use that protocol using native functions provided by .NET or Java, which we enable with the Use Native SOAP property. The SOAP protocol uses the XML standard for the definition of the request and response messages, and the Use Native SOAP property determines the way in which the XMLs will be generated. If set to yes, the XML serialization will use functionalities provided by the platform language. That is, instructions from the .NET framework or Java language will be used to generate the XML at a low level. If set to no, which is the default value, GeneXus will be in charge of generating the XMLs used by the service. GeneXus also provides specific data types to consume WS security web services and predefined constants that make it easier to use these data types. In certain applications, it's very useful for the consumer of a service published by us to be able to send a response to the server that publishes our service. GeneXus allows us to track and route SOAP web services via WS addressing, also enabling the use native SOAP property. WS addressing is a protocol of the World Wide Web Consortium, W3C, that specifies how a service consumer can indicate the endpoint to which the service should send its response, and or send SOAP failures in an invocation. The client sends a SOAP request to the service, and the service infrastructure must handle the request asynchronously, so that the client does not have to wait for the response. The service implementation generates a response and returns it to the service component, which interprets the WS addressing headers and automatically forwards the SOAP response envelope to the URI mentioned in the reply to header. This is done using two structures, headers and endpoint references. The power of WS addressing is that the service consumer can specify to which endpoint the response should be sent. It's not hard-coded in the service implementation. Instead, it's specified by the consumer. Information on the WS addressing data type used by GeneXus can be found in the wiki. Now, let's see what the location of a web service is. Web services run on a web server, so each web service is identified by a URL, from a certain host and on a certain port. It also has other characteristics when it's executed, such as the security it uses, authentication method, credentials, and so on. These values are assigned by default by GeneXus when we publish a web service, and when the web service comes from a third party, the service provider assigns these characteristics. This set of properties that determine where and how a remote service is executed is called location. When invoking a SOAP web service, it's possible to change its location and assign other values than the default ones. This is particularly useful when, for example, we're running a service on a development server and we want to run it on a production server. Although the code that's executed is the same, when the host address and other properties are changed, it's considered a different service from the first one. We can change the location of a web service at generation time to change the default values assigned by GeneXus, or at runtime by code when we consume the web service. Let's go back to the example of the Get Attractions by Country WS procedure that we published as the SOAP web service to obtain data of attractions by country and then consumed from the attractions by country from WS web panel to test it. In the web panel events, where we show the data returned by the service, we can obtain the location of the invoked web service by assigning a location variable of location type with the data returned by the getLocation method, to which we pass the name of the external object as a parameter. This allows us to assign different values to the location properties, such as changing the host, the base URL, the port, the resource name, and other service data. This is very useful when we have a service running on a server, and then we want the service to run on another server. For example, when we move from the development server to the production server, or when we want to reuse a service in another application, and we want it to run on another server. Note that after executing the web service, we use the methods getSoapErr and getSoapErrMessage to obtain information about the result of the execution. We'll look at these concepts in more detail later. The data that we assign to the location of a service can be parameterized in the database. In the example, we create a WS service transaction, and then, with a forEach command, we access the table containing the values of the attributes to assign the location properties. In addition to defining a variable of the location data type and changing the values of its properties by code as we've just seen, another way to assign the values of a location is by using a location.xml file that we place in the web folder of our target environment. For example, the web folder in a .NET model or web.inf in Java. When GeneXus compiles the application, if it finds a file named location.xml in the folder mentioned above, it reads it and assigns the location values dynamically at runtime. The format of the location.xml file is as shown on the screen. In gxLocationName, we assign the name of the external object associated with our web service. Host is the name of the server that will host the service, without including HTTP or HTTPS, that is, only www.servername.com, for example. The port is a numeric value that depends on the type of server. It's recommended that the base URL be between slashes, for example, \services\. Secure with the value 1 indicates that a secure server will be used, that is, with HTTPS protocol and the value 0 for HTTP. Proxy server host and proxy server port are used when there is a proxy server between the client and the server providing the service. Timeout is assigned with the maximum time in seconds that the system must wait for a response to be sent to the server after each request. If the value 0 is assigned, it means that the waiting time is indefinite. Then, if required, the authentication characteristics of the HTTP communication can be defined. The properties assigned at runtime to a variable of the location data type will take precedence over those assigned at runtime through a location.xml file. In turn, the latter will take precedence over those assigned at generation time. This allows for more dynamism in the configuration of locations. When we invoke a SOAP service and assign values to a location variable, we can assign a value to the cancel_on_error property, which allows us to obtain the result of the operation and handle errors. Here's a typical example of use. The behavior of the service will depend on the value assigned to the cancel_on_error property. For example, if we assign the value 0, the program that invokes the web service will always cancel the execution at the end of the invocation. This is the default value. If we assign the value 1, the calling program will cancel the execution if an error occurs. If we assign the value 2, the calling program will not cancel the execution if an error occurs. To obtain information about the error, we can use the functions getSoapErr and getSoapErrMessage. The getSoapErr function returns a numeric value corresponding to the error code of the last soap operation. If the function returns 0, no error occurred. Otherwise, the code depends on the type of error, and it varies if the error occurred in the client or on the server. The getSoapErrMessage function returns a description of the error of the last soap operation, which allows us to give a more user-friendly message. A table of possible error codes, both in the client and on the server, can be found in the wiki article Error Codes and Messages for Location Data Type.